Hey everyone, Miss JC here. This is the second lesson for our online learning, and we are going to be focusing on a couple different things. We're going to learn about how to identify the segment measures, identify congruent segments, and then segment addition postulate. And I'll go over those three here and go over some examples. So you're going to take some notes. So you want to take out a piece of paper, jot down these examples. If we look at the top, the first one we're going to talk about is measuring segments. And when we talk about measuring segments, the distance between 2 points, A and B, they could be called other points, but let's just say A and B. It'll be written as the length of AB. So we want to find the distance of 2 points. We're going to identify this as the length of A to B, or AB. And so the length here on this timeline, this number line over here, is from -1 to 3. And if we need to, we can count how many spaces from A to B, and that's 4 spaces. So the length of AB, or segment AB, is 4. So that's how we measure segments on a number line. To identify congruent segments, as we see over here on the left side, if AB equals CD, then the segments are congruent. So congruent also means equal. This can be written as this. Segment AB is congruent to segment CD. So even though they are different places on the number line, we see that segment AB over here is 4. It has a length of 4. And segment CD has a length of 4. So those segments are congruent. So we can write it like this. And then the last one is talking about the segment addition postulate. And what this is just kind of like a rule when we are adding segments. So it says if A, B, and C are collinear, remember what collinear means? Collinear means on the same line. And B is between A and C. So if you look over here, you can see that the B is a point that's between A and C. If that's true and they're all on the same line, then you can take segment AB, which is this one, segment BC, so from B to C, which is this one, and when you put these segments together and you add them together, they'll give you the length of AC, of the whole length. So I'll give you a couple examples down here. We see B, E, and N. They're all on the same line, so those are collinear points, and you see that E is in between them. So if I say the segment from B to E is 5, and segment EN is 3, has a length of 3. So if these were on a number line, you would see that this has a length of 5, this has a length of 3. If I asked you what BN was, what the length of BN was, well, then it would be 5 plus 3, and you would add them together to get the whole length, which would be 8. Another example would be if I see A, D, and F all on the same line. If I know that AD is 4, and that might be given information, and I know that AF, which is the whole thing, is 10, how could we find this missing value? Well, we know that the whole length is 10, so we would take 10 minus the length of AD, which is 4, and that'll give us this remaining length, which will be 6. So the length of DF would be 6. And if you want to check, you know that 4 plus, I'll put a 6 in here, equals 10. And that's what the given information said. Okay, here's another example. So you might want to draw this picture right here in your notebook, this line segment PQR, and we see that Q, they're all on the same line, they're all collinear points, so we know that when you put them together and you add them together, the lengths together, it'll give you the total length of the whole segment. So let's just read number 1. Number 1 says if PQ is 9, so if I look at this picture, PQ, this length would be 9, so I'm going to put 9 there, and QR equals 28, QR, so Q to R is 28, and then it says find PR. So how do I find the length from P to R? Well, I know that if I add PQ plus QR, that'll give me the total length of the line segment. So if I add 9 plus 28, that gives me 37. That's the length of PR, the total line segment. So it's helpful to draw the picture. So if I want to draw the picture again, because I've already used that one, so let me draw the picture down here. It doesn't have to be perfect, but I'm going to label it P, Q, and R. This example says if QR is 17, so remember this is given information. You don't have to guess. They tell you that the length from the line segment QR is 17. So from Q to R, it has a length of 17. And PR has a length of 21. So P is here, R is here. So that means this whole length is 21. They want us to find PQ. So how do I find PQ? Well, this line, whatever this is, when I add it with the 17, it'll need to give me the total length of 21. So I could look at it like x plus 17 equals 21. And then I can solve by getting rid of the 17 on both sides. So x equals 4. I could also think about, well, if the total length is 21 and I already have 17 of it, I could take away the 17 to see what was left for this length of x. And I'll get the same answer. X has to equal 4. So the length of PQ, always go back to the question. So the line segment PQ has a length of 4. Okay, so for number 3 here, it says it's important to read the question and make sure you're understanding what it's asking for. We're also going to be moving into problems that require a little bit more work in solving. So it says if EG equals 71, so I need to go to the picture and I need to see EG. So it's telling me that this total line segment is 71. So I'm going to write total there because that's the length of the total line. And I'm also going to write that on my paper on work, showing that the total is 71. Then it says find the values of x. So before I can find these values of x, I need to actually use the information that I have, and I'm going to use the segment addition postulate, which says if I add this line segment, EF, and I add this line segment, FG, it'll give me the total. So I'm going to take 8x minus 17, and I'm going to add the 5x minus 3. So I'm adding both of those segments together and then setting it equal to 71 because that's what the problem tells me. And then I know before we left, we talked about solving equations, and after using distributive property, we combine like terms. So before you start solving this, you're going to see if you can combine any like terms. So on this left side, I see that we have 8x plus 5x, so 8x's plus 5x, I'm going to take those coefficients, 8 plus 5 gives me 13x's. And then I see this is a negative 17 minus 3 more, so negative 17 minus 3 is negative 20. And I'm going to bring down the equal sign and the 71. After you combine like terms, now we're going to solve using inverse operations. So remember, the opposite of addition is subtraction, the opposite of subtraction is addition, the opposite of multiplication is division, and the opposite of division is multiplication. So here, this is a two-step equation now. We see if we want to solve for x here, remember we undo addition or subtraction first. So I see subtraction, so I'm going to undo that by adding 20 to get rid of it. Also on the right side, whatever you do on the left, you do on the right as well. So this will cancel out to 0. We're going to rewrite 13x equals 71 plus 20 is 91. And then to solve for x here, divide both sides by 13. So x equals 7. So just go back up to the problem, make sure that's the work that they wanted you to do and that you don't have to do anything with this number. They actually just ask you to find the value of x. So the value of x is 7. Okay, so for this next problem, You're going to want to write these down just like we did for the first couple. It's important to really understand the directions, okay? And so you might want to first start by drawing this picture, TUV, this line segment, and labeling TU 9x plus 2 and then UV 5. You're going to want to label those. So because it gives you both of those segments, we know that if we take 9x plus 2 and we add 5, it's going to give you the total length of TV. So that's the segment postulate that we learned. If we take the first segment, which has this length, and we take the second segment, which is UV, and we take this length, if we add them together, it'll give us our total. So I just wrote them next to each other, 9x plus 2 plus the 5. That'll give me the total line segment of TV. And then if I go look at the directions, it actually tells me that the line segment TV, it can be represented by this. So I'm going to write 9x plus 2 plus 5 equals, and instead of writing TV, I'm going to write what the problem tells me it represents, 14x minus 8. So the question says find the length TU. Well, I know I need to find this length, but I need to solve for x so that I can plug x in there and find the total length. So I have my equation set up now. So solving, remember we combine like terms if they're on the same side of the equal sign. And over here we see a positive 2 plus 5. And we know that 2 plus 5 is 7. So I'm going to write 9x plus 7 equals, I'm going to bring down the 14x minus 8 because I didn't do anything with that. And now we're getting all of the variables on one side and all the constants on the other. So I'm actually going to move this 14x to the left side. How do I do that? I use opposite or inverse operations. So I'm going to take it away. So 14x minus 14x is 0. And then I'm going to take it away on this side as well. So 9x minus 14x is negative 5x. Bring down the plus 5, and then bring down the negative 8. Don't forget that negative that's with it. So now we have all the variables on the left side. Now we see that we need to move this constant that's by itself to the right side. How do I do that? I need to undo what's happening on this left side, which is plus 7. How do I undo that? I'll take 7 away from both sides. So that is 0. So we have negative 5x equals negative 8 minus 7 is negative 15, and I'll solve for x by dividing both sides by negative 5. So I see that x equals 3, but that's not the answer because I know the problem, I remember, and I might need to go back up. I know the problem is asking for me to find TU. So I just found x, which is great, but now I take that x and I need to plug it back in to x for the line segment at once. So if I plug that in, I'm going to go ahead and erase this work. So I have some space to work with. So hopefully you're writing these steps down, pause the video, replay what it is that I said I did and why I did it. And remember, we did this right before we left for school, solving equations. We did a lot of those problems. So going back to your notes on that. So now I found x. So remember what we just said, we want to plug it back into x here. So I'm going to rewrite 9x plus 2. And I know that x is 3 from my work. So 9 times 3 plus 2, 9 times 3 is 27, plus 2 will be 29. So the length of TU is 29. Okay, here's another problem. Remember, I'm going to go over quite a few different practice problems so that you're able to see me work through a couple. You're going to want to write down each one. So I'll give you some time. You can pause the video. Go ahead and draw this picture. So for this one, I would start by drawing this line segment J, K, L, and then labeling where the 27 goes, where the 3x minus 1 goes. So remember our postulate that we're working on. The postulate says that if I take this first line segment, which is 27, And if I add it to the other one, which is 3x minus 1, it's going to give me the total line segment. And the total line segment is JL. From J to L is the total. So now I can go look at my problem and see what information they're giving me. It says if JL equals this. So now I know that JL, which is what I had over here, actually I can write as 5x plus 2. So when I'm doing these problems, I know they might ask me to find a different line segment, but the first thing I need to do is solve for x, or find x, and then plug it back in order to find JL. So again, same type of problem, draw your line down the equal sign. The goal is to get all the x's or variables on one side, constants on the other. Before you do that, see if you can simplify it all. So I see 27, I see minus 1, those are both constants, so I can combine them. 27 minus 1 is 26. And then I'm going to just bring down that plus 3x. I'm not doing anything with that. Bring down the 5x and the plus 2. And now I'm going to solve by moving terms to each side that I need to. So if I want all the x's on the left side, I know I need to move this term over to this side. And I'm going to do it by undoing it. 5x minus 5x will make 0. So now that's gone. Make sure you do it on the left side as well. So I have 26, and then I have 3x minus 5x will make negative 2x. And then don't forget you have a positive 2 left on the side. So again, our goal is to get the variable by itself. We have one step closer. We need to get rid of this 26 over here. So if I take 26 away, that'll make 0. But you also have to do that over here. So what's left on this left side is negative 2x. Bring all of that down, equals, and then 2 minus 26 is negative 24. And then if I divide both sides by negative 2 to solve for x, I see that x equals a positive 12. Again, that's not my final answer. It's one step closer. But remember, my final answer is to find JL. So that is the total length. So for here, I'm going to have to do a little bit more work. But now I know what x is. So I can plug my answer, my value for x, back into what the problem is giving me. So take a minute to copy this down. Pause the video. Make sure you understand how we solve for x here. And I'm going to go ahead and erase this work so that we can show the next set of work. I'm going to leave my answer at the bottom. So we have x equals 12. So you might have to read the question a couple times here, asking what it's asking you to find. So I'm just going to erase all this so it can be a clean slate. So the problem is asking us to find JL. Where's JL? Here's J. Here's L. It's asking me to find the total. So I know that this is 27. And I know if I add it to 3x minus 1, it'll give me the total. And now I know that x is 12, so I'm going to put a 12 in for x and rewrite everything else. So 3 times 12 is 36. 27 plus 36 minus 1 will give me, let's see here, 27 plus 36 is 63. Minus 1 is 62. That's the total for line segment JL. So 2 steps here. We solved for x first, and then we plugged it back into what we needed to find what the question was asking for.